Hey, and welcome to another episode of Physiology with Shakti. And in today's episode, let's try to understand a bit about how ABO blood group system works and how the antigenic properties of that come into being and the relationship between that and the genotype. So when you talk about the ABO blood group system, it is actually nothing but a presence of a certain set of polysaccharide units which makes it get segregated into different types of blood group. So there are polysaccharide units. That is the first thing you need to understand. This polysaccharide unit has a very basic structure, and on top of that basic structure, when you add different components based on what component is added because of the process of certain set of genes, they end up becoming different blood group. That is, they have various antigenic properties based on which structure is added to the base structure. So to begin, let's start by understanding what this base structure is, the base polysaccharide chain that is it. So we got your basic glucose which is present. There's a glucose, and then you need to understand that there's a galactose and N-acetyl galactosamine followed by another galactose. Just remember this, glucose is the basic thing. And after that, if you know my name is Shakti Nag, right? So Nag is in the center, and the side of Nag are two girls. So GAL. So glucose, galactose, and at the center NAG, Nag, that is N-acetyl galactosamine. This forms your basic structure, which is there regardless of which blood group it is. Now, because of the presence of certain set of genes, different components are added. So there are a set of transferase genes which are present in different chromosomes. So the first thing is, before the addition of these things, you need the base structure to be fucosylated. Why do we need that? Whenever we build a house or any other building for that matter, we need to have a base, right? The foundation should be laid first, and on top of that you need to build up everything else. In the absence of that foundation, everything else crumbles down. So we need that basic structure in order to bring about the next structures into it. So that is why in chromosome 19 there is a fucosyl transferase which is present. So we have a H gene in the chromosome 19 which has a fucosyl transferase, and the fucosyl transferase will end up giving a L-fucose to this chain. So we got a glucose, galactose, and acetyl galactosamine, galactose. To that you add another L-fucose. This fucosylated polysaccharide unit is the base. So from the H gene you got the fucosyl transferase which gives a L-fucose. So this is there regardless of what blood group it is. Now to this base structure you have to add certain set of components, and that is transcribed by your chromosome number 9. And in chromosome number 9 we got two sets of things that can either result in what forms the A blood group or what forms the B blood group. So in case there is a transferase which is called galactosamine transferase, there is addition of N-acetyl galactosamine to this fucosylated polysaccharide that we just saw. So to this fucosylated polysaccharide, if I were to add an N-acetyl galactosamine, it would result in a A blood group. As I said earlier, Nag is me, I'm the first one. So A, right? So N-acetyl galactosamine added into this will form a A blood group. Now instead of this, if in chromosome 9 you had a galactosyl transferase which simply adds another galactose unit. So when a galactose is added instead, it forms a B. So galactosamine and acetyl galactosamine is added, it forms a A blood group. When galactosyl is added, it forms a B blood group. What you have to understand is A is dominant, B is also dominant. So what happens when both the genes are present together, A and B? Galactosamine transferase and acetyl galactosamine transferase, they seem to be co-dominant, and both of them together will form what is called the AB blood group. Presence of both this antigenic variants will phenotypically come out as AB blood group. So we've seen A blood group, which is dominant, we've seen B blood group, which is again dominant, and next is AB blood group, which is codominance. Now, in the absence of either of this, you form what is called the O blood group. So O blood group simply does not have any other extra additions, but instead is just your base structure. That is your fucosylated glycoprotein that I had talked about earlier, which came from the H gene. So when we say O blood group, it does not mean there is no antigen. There is a fucose which is added from the H gene. So there are some individuals, very rare amount of the population, 0.01% of the population, seem to have a disorder called the Bombay blood group. So in these individuals, what happens is this H gene has an abnormality, because of which even the base is not formed. So remember what I said, while building a house, you need the foundation to be present in order to build the house, right? And if that foundation is not there, it will soon crumble down and we cannot add more things on top of it. So in failing to do so, even if there is presence of either A or B or AB present genetically, it cannot phenotypically express itself. So the person might seem like O blood group, but instead he doesn't even have the H. So according to Landsteiner's law, we know that if a particular antigen is not present, the antibody corresponding to that is going to be present. The antibody corresponding to that is going to be present. In these individuals, an antibody against a normally occurring base structure is now coming. What happens? This person who might seem like an O blood group, the second we give him or her a O blood group transfusion, you will see that because of the presence of antibodies against the H antigen, now there will be transfusion reactions. So this is the thing that we need to understand about them. So let's just recap the structures again. We got the glucose, galactose, and a cell galactosamine, galactose, and to that you add a fucose, this base structure which is present in O blood group. Now you add an acetyl galactose to it, that forms the A blood group. You add a simple galactose to it, it forms the B blood group. When both of them are there together, they form AB blood group. Now that you understood this basic concept of what makes up the different blood groups in the ABO blood group system, you can go on to understand more things further. So thank you, that's it for now.